An onboard generator for a recreational vehicle is typically not considered a separately derived system. It is a part of the recreational vehicle's electrical system and is connected to the same grounding and bonding system. A neutral to case bond is not typically present in onboard recreational vehicle generators. This bond is usually only found in generators that are used as standalone power sources. Onboard recreational vehicle generators usually have a transfer switch that allows the recreational vehicle to switch between shore power and generator power. Onboard recreational vehicle generators may have several 120 volts and 12 volts receptacles. These receptacles are typically wired as follows. For 120 volts receptacles, they are wired to the generator's alternating current output connected to the recreational vehicle's neutral and hot bus bars and grounded to the recreational vehicle's chassis ground. For 12 volts receptacles, they are wired to the generator's 12 volts direct current output connected to the recreational vehicle's 12 volts direct current system and grounded to the recreational vehicle's chassis ground. The generator's frame should be bonded to the recreational vehicle's chassis ground. The generator's exhaust system should be properly grounded. The generator should be installed in a well-ventilated area and protected from moisture. When discussing generator systems, there are a few key concepts to keep in mind. Firstly, understanding what constitutes a separately derived system is crucial. A separately derived system is an electrical power source, such as a generator, that is not electrically connected to the main power source of a building or structure. This means the generator's neutral conductor is isolated from the building's neutral. In the context of recreational vehicles, onboard generators are generally not considered separately derived systems because they are integrated into the vehicle's existing electrical system. The generator's neutral is typically connected to the recreational vehicle's neutral bus bar, which is also connected to the chassis ground. Secondly, the neutral to case bond is another important aspect to consider. This bond refers to the connection between the neutral conductor and the generator's metal frame or enclosure. In separately derived systems, this bond is required to establish a proper ground reference for the generator's output. However, in onboard recreational vehicle generators, a neutral to case bond is usually not present. This is because the recreational vehicle's electrical system already has a grounding system in place, and adding another neutral to case bond could create multiple ground paths, leading to potential safety hazards. Thirdly, transfer switches play a vital role in recreational vehicle generator systems. A transfer switch is a device that allows the recreational vehicle to switch between shore power, which is the external power source, when the recreational vehicle is plugged into an electrical outlet, and generator power. The transfer switch ensures that only one power source is connected to the recreational vehicle's electrical system at a time, preventing backfeeding and potential damage to equipment. Fourthly, onboard receptacles are essential for providing power to various appliances and devices within the recreational vehicle. These receptacles are typically available in both 120 volts alternating current and 12 volts direct current configurations. The 120 volts alternating current receptacles are wired to the generator's alternating current output and connected to the recreational vehicle's neutral and hot bus bars. The 12 volts direct current receptacles are wired to the generator's 12 volts direct current output and connected to the recreational vehicle's 12 volts direct current system. All receptacles are grounded to the recreational vehicle's chassis ground for safety. In addition to these key concepts, there are a few additional considerations to keep in mind when dealing with recreational vehicle generator systems. Firstly, the generator's frame should always be bonded to the recreational vehicle's chassis ground. This ensures that the generator is properly grounded and helps to prevent electrical shock hazards. Secondly, the generator's exhaust system should also be properly grounded. This helps to dissipate static electricity and prevent potential fire hazards. Thirdly, the generator should be installed in a well-ventilated area and protected from moisture. This helps to ensure that the generator operates safely and efficiently. To further clarify the wiring of 120 volts alternating current receptacles, it is important to understand the role of the neutral and hot bus bars. The neutral bus bar is a conductor that is connected to the neutral point of the generator's alternating current output. It provides a return path for the alternating current electricity. The hot bus bar is a conductor that carries the live alternating current electricity from the generator to the receptacles. The 120 volts alternating current receptacles are wired with one terminal connected to the neutral bus bar and the other terminal connected to the hot bus bar. This provides the 120 volts alternating current electricity needed to power appliances and devices. Similarly, the wiring of 12 volts direct current receptacles involves connecting them to the generator's 12 volts direct current output in the recreational vehicle's 12 volts direct current system. The 12 volts direct current system is typically powered by the recreational vehicle's batteries, which are charged by the generator. The 12 volts direct current receptacles are wired with one terminal connected to the positive terminal of the 12 volts direct current system and the other terminal connected to the negative terminal of the 12 volts direct current system. This provides the 12 volts direct current electricity needed to power lights, fans, and other 12 volts direct current devices. It is also important to note that all receptacles in the recreational vehicle should be grounded to the recreational vehicle's chassis ground. This is typically achieved by connecting the ground terminal of the receptacle to the recreational vehicle's metal frame or chassis. The chassis ground provides a low impedance path for fault current to flow back to the source, which helps to trip circuit breakers or fuses and prevent electrical shock hazard. When working with electrical systems, it is always important to follow all safety precautions and local electrical codes. If you are not comfortable working with electricity, it is best to consult a qualified electrician. In summary, onboard recreational vehicle generators are typically not considered separately derived systems and do not have a neutral to case bond. They usually have a transfer switch for switching between shore power and generator power and onboard receptacles for providing power to appliances and devices. The receptacles are wired to the generator's alternating current and direct current outputs and grounded to the recreational vehicle's chassis ground. The generator's frame and exhaust system should also be properly grounded, and the generator should be installed in a well-ventilated area and protected from moisture. The National Electrical Code, or NEC, provides guidelines for the installation and wiring of electrical systems, including those in recreational vehicles. Article 551 of the NEC specifically addresses recreational vehicles and recreational vehicle parks. This article covers topics such as wiring methods, overcurrent protection, grounding, and bonding. It is important to consult the latest edition of the NEC for the most up-to-date requirements. Some key NEC requirements for recreational vehicle electrical systems include: firstly, all 120 volts alternating current and 12 volts direct current circuits must be protected by overcurrent devices, such as circuit breakers or fuses. Secondly, the recreational vehicle's electrical system must be grounded to the chassis. Thirdly, all metal parts of the recreational vehicle's electrical system must be bonded together to create a low-impedance ground path. Fourthly, receptacles must be of the grounding type and properly grounded. Fifthly, ground fault circuit interrupter, or GFCI, protection is required for receptacles located in certain areas such as bathrooms and kitchens. Sixthly, arc fault circuit interrupter, or SI, protection may be required for certain circuits. In addition to the NEC, there may be other local codes and regulations that apply to recreational vehicle electrical systems. It is important to check with your local authorities to ensure that your recreational vehicle's electrical system meets all applicable requirements. When selecting a generator for your recreational vehicle, it is important to consider the power requirements of your appliances and devices. You will need to choose a generator that is capable of providing enough power to run all of your electrical loads simultaneously. It is also important to consider the generator's noise level, fuel efficiency, and size. Generators are typically rated in watts, which is a measure of electrical power. To determine the power requirements of your appliances and devices, you can check the nameplate on each appliance or device. The nameplate will typically list the voltage, amperage, and wattage of the appliance or device. To calculate the total power requirements of your recreational vehicle, you will need to add up the wattage of all of the appliances and devices that you plan to use simultaneously. It is important to choose a generator that has a wattage rating that is higher than your total power requirements. This will ensure that the generator is not overloaded and that it can provide enough power to run all of your appliances and devices. In addition to wattage, it is also important to consider the generator's surge capacity. Surge capacity is the amount of extra power that the generator can provide for a short period of time. Some appliances and devices, such as air conditioners and refrigerators, require a surge of power when they start up. It is important to choose a generator that has a surge capacity that is high enough to handle the starting surge of these appliances and devices. When installing a generator in your recreational vehicle, it is important to follow all of the manufacturer's instructions. The generator should be installed in a well-ventilated area and protected from moisture. The generator's exhaust system should be properly vented to the outside. The generator should be securely mounted to the recreational vehicle's frame. The generator should be connected to the recreational vehicle's electrical system by a qualified electrician. Regular maintenance is essential for keeping your recreational vehicle generator in good working condition. You should check the generator's oil level, air filter, and spark plugs regularly. You should also clean the generator's cooling fins and inspect the wiring for any damage. If you notice any problems with your generator, you should have it repaired by a qualified technician. By following these tips, you can ensure that your recreational vehicle generator provides you with reliable power for years to come. The grounding and bonding of electrical systems is crucial for safety. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers or fuses and prevent electrical shock hazard. Bonding connects all metal parts of the electrical system together to create a low-impedance ground path. This helps to equalize the voltage potential between different metal parts, which reduces the risk of electrical shock. In a recreational vehicle, the chassis ground serves as the main grounding point for the electrical system. All metal parts of the electrical system, including the generator frame, receptacles, and appliances, should be bonded to the chassis ground. The grounding conductor, which is typically a green or bare copper wire, connects the grounding terminals of receptacles and appliances to the chassis ground. The size of the grounding conductor must be adequate to carry the maximum fault current that is likely to occur. The NEC provides tables that specify the minimum size of grounding conductors based on the size of the overcurrent protection device. Ground fault circuit interrupters, or GFCIs, are another important safety device for recreational vehicle electrical systems. GFCIs are designed to detect ground faults, which occur when current leaks from a circuit to ground. When a ground fault is detected, the GFCI will quickly trip the circuit, cutting off the flow of electricity and preventing electrical shock. GFCIs are required for receptacles located in certain areas of a recreational vehicle, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, RFCIs, are another type of safety device that is becoming increasingly common in recreational vehicle electrical systems. RFCIs are designed to detect arc faults, which are dangerous electrical arcs that can cause fires. When an arc fault is detected, the RFCI will quickly trip the circuit, cutting off the flow of electricity and preventing a fire. The NEC may require RFCIs for certain circuits in a recreational vehicle, such as bedroom circuits. When working with recreational vehicle electrical systems, it is important to use the correct wiring methods. The NEC specifies the types of wiring methods that are permitted for use in recreational vehicles. Some common wiring methods include non-metallic sheathed cable, or Romex, and flexible metal conduit. All wiring must be properly supported and protected from physical damage. The wiring must also be sized correctly to carry the maximum current that is likely to flow in the circuit. The NEC provides tables that specify the ampacity of different types of conductors based on their size and insulation type. Overcurrent protection is essential for protecting recreational vehicle electrical systems from damage. Overcurrent protection devices, such as circuit breakers and fuses, are designed to trip the circuit when the current exceeds a safe level. This prevents the wiring from overheating and potentially causing a fire. The size of the overcurrent protection device must be matched to the ampacity of the wiring. The NEC provides tables that specify the maximum size of overcurrent protection devices for different types of conductors. Regular inspection and maintenance of recreational vehicle electrical systems is important for ensuring safety and reliability. You should inspect the wiring, receptacles, and overcurrent protection devices regularly for any signs of damage. You should also test the GFCIs and FCIs to ensure that they are functioning properly. If you notice any problems with your recreational vehicle electrical system, you should have it repaired by a qualified electrician. By following these guidelines, you can ensure that your recreational vehicle electrical system is safe and reliable. Remember to consult the latest edition of the NEC and any applicable local codes and regulations for the most up-to-date requirements. Safety is paramount when dealing with electricity. Always take precautions to protect yourself from electrical shock and fire hazards. If you are not comfortable working with electricity, it is best to consult a qualified electrician.